Quiz 8. Let's see how we did. The number 33 has how many significant digits? Well, that's an easy one. There's only 2 digits there, so it has to be 2. Okay, good. And the number 1,000. Remember, there's no decimal point here, so these 3 zeros are not significant. And so the number of significant digits is 1. And the number 33.0, this 0 is at the end of the number and to the right of the decimal point. So all 3 of those are significant. The number 0.0030, well, zeros before a number are not significant, and so it has 2 digits that are significant. The number 330, notice there's no decimal point, so this 0 is not significant, just these first 2 digits are. So there are only 2 significant digits here. Now if it said 330 decimal point, well then yeah, we'd have 3 significant digits, but here it just has 330, so there are 2. 410.0, notice how it has that decimal point 0. All 4 of these digits are significant, so there are 4 of them. The number 0.530, zeros before a number are not significant. 530, zeros after a number and to the right of the decimal point are. There are 3 significant figures here. 0.001. Remember, it doesn't matter how many zeros you shove before a number. They are not significant, right? Only zeros at the end of the number and to the right of the decimal point. So 7.010, this 7 is significant, this 1 is significant. This 0, because it's between 2 significant digits, is significant. And this 0, because it's at the end of the number and to the right of the decimal point, is significant. We have 4. This number, 0.10050. Well, zeros before a number are not significant. So we have this one, and this 5 is significant. And zeros between 2 significant digits are significant. And this 0, because it appears at the end of the number and to the right of the decimal point, is significant. So we have 3, 4, 5 different significant digits here. The number 1.00 has 3 significant digits. 1, and then both of these zeros are significant because they come at the end of the number and to the right of the decimal point. But this number 3070, you see, look at this number 3070. Right there, those 2 digits are significant. That 0, because it's between the number, is significant. But this 0, yes, it is at the end of the number, but it is not to the right of the decimal point. So it is not significant. And there's no decimal point there. So there are only 3 significant digits there. This number, 3,000, how many significant digits does it have? Well, that decimal point right there forces that one to be significant. And you know 3 is significant, and zeros between 2 significant digits are significant. So there are 4 significant digits there. The number 4300240, 0 has how many? Well, we have 1, 2, 3, 4, and 5, 6, because those zeros are between significant. And this one here, because it's at the end of the number and to the right of the decimal point, you know that is 2. So that gives us 7 significant digits for that one. 900.10. Well, we know this one is, and we know this one is, and these 2 zeros, well, they're between 2 significant digits, so you know they're significant. And this 0 is at the end of the number and to the right of the decimal point. So we get 5. 0.31, 0 in front of the number doesn't count. We just have 2 digits that are significant. 3,300, notice there's no decimal there. So we know that these two are significant, but these other two are not. So there are only two significant digits. 62.01, well, this one and this one and this one, and you know this 0 is significant because it comes from in between two significant digits. So there are 4. All right, now let's look at some other ones here. So here's some scientific notation. 5.10 to the third. You know, this really doesn't matter, this times 10 to the third. We're only concerned with this number here. And we have 1, 2, and this 0 is at the end of the number and to the right of the decimal point, so that's 3. 3 significant digits. This one, 1, 2, 3, 4. 4 significant digits right there. Zeros at the end of the number and to the right of the decimal point are significant. Now, these zeros here, now again, you could tell by looking at this that, hey, this is not written in correct scientific notation. Well, that happens all the time. Numbers, some people put down they think is scientific notation, but this clearly is not written in correct scientific notation. Remember, m times 10 to the n, where m is a number that is greater than or equal to 1 and less than 10. And n is defined to be a whole number. And so we have to have that definition. This is clearly much less than 1, so it doesn't fit that definition. But anyway, we want to know how many significant digits there are, and zeros before a number are not significant. This 0 was at the end of the number and to the right of the decimal point, so there are 2. 420 times 10 to the 6th. Again, this number is much larger than 10. It's not written in correct scientific notation, but we just want to know how many significant digits there are. And because this 0 is significant, and this 2 then and 4 are significant, and you know this middle 0 is significant because it's between two significant digits. So again, this 0 is significant at the end of the number again and to the right of the decimal point. So that gives us 4 significant digits in that answer. The number 300 times 10 to the second, there's no decimal point, so you know these two cannot be significant. There is only one significant digit there. 300 decimal point, yep, now this one is significant. And this is significant, and zeros between are significant, so we have 3. Now we have to write using the correct scientific notation, make sure we have the right units and the right number of significant digits. So we got a lot of work for this one. 5.10 times 10 to the third. Well, this number fits the definition of scientific notation just as it is. And notice it has 1, 2, 3 significant digits. Therefore, my answer has to have 3 significant digits. 5.10 times 10 to the third. And units of meters, because that's the unit. So notice that these others, just 5.1 times 10 to the third, this number only has 2 significant digits. But this number has 3. So that one, even though it's close, doesn't have the same meaning as this one. So we have 4.900 times 10 to the negative 4 kilometers. And we want to write this in scientific notation. And yes, this is already written in correct scientific notation. And we have 1, 2, 3, 4 significant digits. So 4.900 times 10 to the negative 4, that's the correct one with units of kilometers. Good. 0.0030 to the negative 1 grams. Well, zeros before are not significant, and so we have 1, 2, 3. So we have to the negative 2 to the negative 3 to the negative 4 grams. 3.0 to the negative 4 grams because those digits are significant. So now we have 420 times 10 to the 6 meters squared. Write the correct number of scientific notation units and significant digits. Okay, so this is to the 6. We have 1, 2, 3, 4 significant digits. So we need to bring this over. This 420 is too big. So what we need to do is write a number that is 4.20 times 10 to the 8th. 4.200 times 10 to the 8th, because we have to get 4 digits. Wow, 4.200 times 10 to the 8th. And it says meters squared. So we have to have units of meters squared. So we have to pick this one. So that's kind of a tricky one because it looks like either one of those, but this is meters squared, which matches there. So be very careful. 300 times 10 to the 2nd Newton. Again, we only have one significant digit here. My answer can only have one significant digit. Times 10 to the 2, I bring that over, 3, 4, 3 times 10 to the 4 newtons. 3 times 10 to the 4 newtons. I see I tried to get it a little tricky there and put different units here to see if you made sure that you were watching. So 3 times 10 to the 4th newtons. Write 300 decimal point to the 2nd pascals. Okay, so we have to move this decimal point over. Now there's 3 significant digits. See how there's only one significant digit here? But here there's 3. And so with 3 significant digits, our answer has to have 3. So I move that decimal point over. So it's not just going to be times 10 to the 3rd, 10 to the 4th. It's not going to be just 3 times 10 to the 4th. It's going to be 3.00 times 10 to the 4th in units of Pascal. So that's an introduction to significant digits. So make sure you understand them, and the next 2 days we're really going to refine our skills on them. So the problems get a little harder, and that's okay. Just make sure you follow the basic rules and you'll do just fine. Good luck to you.